Hello students, today we'll discuss about how we can perform the first practical that is named as to measure the characteristic impedance of two-port symmetrical T and pi network. Okay, so this is a DC power supply. Okay, and we are having three different power supplies over here mentioned by A, C and B. And the specifications for A is that if you see, that is the first power supply is corresponding to A, okay. Second is corresponding to B, and the third one is corresponding to second is corresponding to C, as it is being mentioned over here, and this is B over here, if you can see under the knob. Okay, so currently I'm using power supply A. So this is my black terminal, which is a ground, and this is my positive voltage, which is considered as the red. And these are the connecting wires that we will be using in our breadboard connections to make the complete circuit. Clear? This white board is basically known as a breadboard. Okay, and over here, first of all, let me introduce with the DC voltmeter. Okay, DC voltmeter in the sense that it can have maximum that is voltages up to 30 or 50 volt, and if we want to measure 30 volt, then we can connect this particular wire, okay, connecting wire to that 30 volt. Otherwise we can connect this to the 50 volt. Okay, so we are having two scales, one is for the 30 and another is for the 50 volt. Similarly, we also have a DC ammeter. Its rating is from 0 to 30 milliampere. Okay, so this is from 0 to 30 milliampere. Here I am having only a single scale because I have only one slot from where I can measure up to 30 milliampere. But in case of the voltmeter, it is being calibrated with the two scales because we are having the options whether I want to calculate for maximum 30 or for maximum 50 volts. Okay, and black one, which is being mentioned as a common, is a ground terminal. Clear? Now let us start first of all with the connections. As you know that in case of symmetrical T network, as we know that in case of symmetrical T network, we are having two series arms, and over here you might be able to see that the impedances are Z1 by 2. And since we are going to consider the same impedance value, so value for both the resistances we are considering as 830 ohm. And in the shunt arm, we are having Z2 that we are considering as 2.2 kilo ohm. And even we can consider the different value resistances in that is for the shunt or for the series. But make sure that both value of these impedances connected in series should be same. And over here we are having that kind of the arrangement. If you see that this is a green colored and there are some color codes mentioned over here, so this is being considered as my first series arm, this is my another series arm, and this is my shunt arm. Okay, so how these are being connected, okay, that is properly visible from here. Clear? Let us now start making connections. In order to start, first of all we will be calculating, as we know that we have to calculate the characteristic impedance. So characteristic impedance will be calculated in terms of, that is characteristic impedance is basically square root of open circuited impedance and short circuited impedance. Okay, so theory part, as you are aware of that how we can calculate the open circuited and short circuited. One time we have to consider the open terminals. If I am just calculating the Z01, that is characteristic impedance looking from input port, in that case this is my output port, okay, or I can call it as a port 2. So over here for one time I will be considering it as open, for another time I will be connecting it with one jumper wire to make it a short connections. Clear? Similarly, the same procedure we have to repeat by checking that impedance looking from the, that is output port 2, and repeating the same procedure over here at the input by making it as a open or short circuit connections. Okay, objective of this particular experiment is that we need to calculate, if I am calculating this impedance from the port 1, this is being considered as my port 1, or this is considered as my input port, whatever the impedance I am calculating. So here I am also specifying that Z01 may be that is considered as the open circuited impedance calculated at input port. Similarly, the short circuited impedance calculated at input port. So this is the impedance I am calculating at input port. Okay, similarly the same procedure we have to repeat at the output, or that is we can say at the port 2. So this is my port 1. Okay, similarly we have to calculate Z02 characteristic impedance at output port, and again the concept is that the open circuited impedance calculated at port 2 and the short circuited impedance calculated at port 2. Okay, that means that we will be calculating it at output port. Okay, that means it is port 2. Objective is that whatever the impedance we are calculating, Z01 should be equals to Z02. That we have to satisfy this condition. Okay, the same concept we have to also fulfill in case of the symmetrical pi network also.